Welcome to the first part of 3.5. Today we're going to introduce matrices. Something that I think a lot of you will enjoy. There are no new vocab terms for this part. So the first thing we're going to talk about is what is a matrix. And all a matrix is a different way to organize data that uses multiple variables. So for example, we've got different levels of work versus their wages and their sales. So there's 6 different things that we're talking about here. And so this is a way to organize it. So this 900 goes with entry level position, their wage. Okay. Sales, this 145,000, again, entry level with sales. So basically the numbers for this represent what are intersected here. So entry and wages, we've got assistant with sales, associate and wages. Okay, so basically it's where each of them meet. So, makeup of a matrix. Okay, so how we use matrices, we have rows. Okay, so rows are the horizontal, and we've got columns. Okay, columns are the vertical. Oops. Okay, so we've got rows. So row 1 would be ABC, row 2 would be DEF, row 3 would be GHI. We could also do column 1, which would be ADG, column 2 would be BEH, column 3 CFI. Okay, so we've got rows and we've got columns. The first thing we're going to talk about is finding the dimensions of a matrix. So to determine the dimensions of a matrix, you would take the number of rows and the number of columns and write it like you would a multiplication problem. So for example, if we bring this one back here, we've got row, 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 column, column. So there are 3 rows and 2 columns. We would consider this a 3x2 matrix. That's what I mean by write it like you would a multiplication problem. It looks like we're going to do 3 times 2. But really, it's considered a 3x2 matrix, and that's how we would write it. So we're going to find the dimensions of all of these. So if I look at this first one on the top left, I've got 2 rows, and I have 3 columns. I would write this as a 2x3 matrix. Okay. For the next one, I've got 1, 2, 3 rows and 1 column, so I would call this a 3x1 matrix. Okay. For the next one, I've got 1 row, 2 columns, so I would call this a 1x2 matrix. And for the last one, I've got 1, 2, 3 rows and 1, 2, 3, 4 columns, so I would call this a 3x4 matrix. Go ahead and pause the video, find the dimensions of this last one before hitting play and seeing how you did. Okay, you should have counted that there are 5 rows and 5 columns, giving us a 5x5 matrix. Next thing we're going to talk about are the elements of a matrix. So elements of a matrix consist of the numbers inside the matrix. So here, 2 is an element of this one, 4 is -1, 1, 6, and -3. Those are all elements of this matrix because they're listed inside of the matrix. The number of elements in the matrix can be found by simply counting the number of values. So 1, 2, 3, 4, 5, 6. There are 6 elements in this matrix because there are 6 numbers inside of it. The last thing we can do is we can ask you to find a certain element, and we use that by using the row and the column that the element is placed in. So they'll use whatever letter they designate the matrix as. Usually it'll be A if there's 1, or if it'll do A, B, C if there's 3 of them. But then they'll do the row number and then the column number. So if they give you A1, 2, that means they want row 1, column 2. So if we've got 1, 2 rows, row 1 is this one, column 1, column 2, column 3. They want this column, row 1, column 2, That's going to be the number 4 is A1, 2. Okay, so we've got a different matrix here, and we've got 3 different numbers that we're trying to find. So for this first one, if they do A1, 3, that means we're looking for row 1, column 3. So row 1 is right here, column 3 is here. The number at the intersection of those two is a -10. Same thing for the next one. A22 means row 2, column 2, row 2, column 2. At the intersection of those is 8. Go ahead and pause the video and find the last one for A32 and then hit play and see how you did. Okay, so you should have known that A32 means row 3, column 2. And if you look here, row 3, column 2 intersects at -3. So now we're going to talk about special types of matrices. Now there's 5 total. We've got 3 on this slide, 2 on the next one. First type of matrix we're going to talk about is a square matrix. A square matrix has the same number of rows as columns. So here, this first one, we have a 2 by 2 matrix. Same number of rows as columns. This one right over here, that's a 3 by 3 matrix. Okay, same number of rows and columns. And you could have a lot of other ones. You could have a 4 by 4, 5 by 5, 6 by 6. Basically, as long as your first number is the same as your second one, you're going to have a square matrix. Next one we've got is a row matrix, and that's a matrix that only has one row. It doesn't matter how many columns are in it, as long as you've only got one row in the matrix, we would call that a row matrix. Similarly with column matrix, a column matrix is a matrix with only one column. So one column in the entire matrix means that it is a column matrix. Now none of these have anything to do with the numbers that are inside. It only depends on the number of rows and the number of columns. These last two matrices, it does matter what's inside of the matrix, so that's why we broke them up this way. So the first one is a zero matrix, and a zero matrix is a matrix where all of the elements in the matrix are 0. So it doesn't matter how many rows, how many columns, okay, it can be any type of dimensions that you want. If all of the numbers inside are 0, we would call that a zero matrix. So here's 4 examples for you right there. Lastly, we have an identity matrix. Now an identity matrix has to be a square matrix, so the rows and the columns have to be equal. Now, what we need to do with the identity matrix is we take the elements that form a diagonal from the top left to the bottom right. So top left to bottom right in all of them. And all of the numbers in that row or that diagonal are going to be a 1. And then the rest of the elements are 0. So these are how they have to look. Okay? Diagonal is 1s, the rest is 0s. Diagonals are 1s, the rest are 0s. Diagonal is 1, the rest are 0s. And it has to be that specific diagonal. It can't be any diagonal or any row or any column. It has to be the one diagonal from the top left to the bottom right is 1, and everything else is a 0. Now some matrices can be more than one type of special matrix. So I've got a few examples here. If you look at this first one, if you'll notice, I've got 2 rows, 2 columns. That makes it a square matrix. Also, I've got the diagonal is 1 and the rest are 0s. That's an identity. So it is both a square and an identity matrix. Okay. This second one, you'll notice I only have 1 row, so that makes it a row matrix. And all of the elements are 0, which would make it a 0 matrix. So it's both a row matrix and a 0 matrix. For this last one, I only have 1 column, which makes it a column matrix. And again, all of the elements are 0, so it also is a 0 matrix. So it's a column matrix and a 0 matrix at the same time. So I've got these 8 matrices on here. I want you to classify them using the special matrices that we did. So pause the video, do all 8, and then hit play and see how you did. Okay, so the first one That is just a square matrix. So yes, it looks like it might be an identity, but remember, it's got to be this diagonal that's got the ones in it and the rest are zeros. So since it doesn't have that, it's not identity. The next one over is just a simple row matrix. Third one, we've got a row matrix and a zero matrix because there's one row and all of the elements are zero. Top right, we've got a square matrix and a zero because it's a square because there's just as many rows as there are columns. It's 3 by 3 and every element inside is a zero, so it's a square and a zero. Bottom left, that one's just a square matrix. Again, it looks like it might be identity because it's got the zeros and the ones, but again, it's got to be this diagonal right here that's got ones in it and the rest are zeros. So it's just a square, it's not identity. The next one over, that's a column and a zero because there's only one column and all of the elements are zero inside. This one, the next one is the square and it's an identity because again there's the same number of rows as columns and again it's got that diagonal here of ones and then the others are zero, so it's both a square and an identity. The last one, that's just a column because there's just one column inside, so it's not going to be a zero or an identity.